Alright, we'll start here and say use the given information to fill in the numbers of elements for each region of the Venn diagram. So we start with this Venn diagram right over here. This is what we're concerned with. And we're going to use each one of these statements down here to go ahead and help us determine which region has which numbers associated with it. So first we'll start with this one. And we remember that n of means the number of elements. So anytime we have an n in front of and there's something in here, this is going to be the number of elements. So let's start with the number of A intersect B intersect C. Now if we look at this very carefully, we understand that A intersect B intersect C is going to be where the three circles overlap, A, B, and C. And this is going to be region W. So when we have region W, that means that 8 goes into region W. So up here, 8 will go into this space for region W. Now, the next one that we're going to look at is going to be n of C intersect A complement. Now, in order to understand what this one is, we want to go ahead and use our Venn diagram to flesh out what we're looking at. So what is C? Well, C is going to be everything in this particular circle right here. And then we're going to talk about A complement. A complement is going to be everything that's outside of the circle A. So we'll go ahead and we'll do this. Everything that's outside of A is going to be this, and this, and this, and this. But we're looking for the intersection of where it's pink and blue. And in this particular case, that's going to happen right here and right here. That means that we're looking at the fact that region Z and region P are equal to 23. So over here, we're going to have Z plus P is equal to 23. I can't do anything with that yet because I don't know what either Z or P is, and I'm going to need to figure that out at some point. And I'm just going to go ahead and write down the fact that W is equal to 8 right here, and that will help me as I progress through this. And then we're going to look at the next one, which is going to be the number for the intersection of A prime, B prime, and C prime. So we need to understand where A prime is, B prime is, and C prime. Now, where is that? Well, let's go ahead and clear this area, and let's consider A prime, or A complement. A complement is going to be everything that's outside of A, which is going to be all of these. B complement is going to be everything that's outside of B. So let's examine what that looks like. And that's what we're looking at. And then we're going to talk about C complement, which is going to be everything that is outside of C. And everything that's outside of C is going to be this. So now, when we examine this, we realize that everything that's outside of A, everything that's outside of B, and everything that's outside of C, when they intersect, is going to be this particular region. And that's going to be right here. And that's going to be region R. So we can go ahead and say that for this, R is equal to 7. So we can put 7 right here. Now, let's move on to the next one. And that's going to be this one right here. We're going to have the number of A intersect B. Well, what's A intersect B? That's going to be 16. And A intersect B is going to be where A and B overlap. So we look at A. This is A. And then we're going to look at B. And this is B. Okay, so here's circle A or set A, which comprises the regions M, Y, W, and X. And then we're going to combine that with region B, which comprises the regions N, X, W, and Z. And we'll notice that the two overlap right here in the orange area, and that's going to be my intersection. Now notice that I have regions X and W here. So let's go ahead and write that down over here. We note that this is going to become regions X plus W, and that's going to be equal to 16. But remember that we've already figured out what W is. W is 8. And that means that I'm going to end up with X plus 8 is equal to 16, and therefore X is equal to 8. So I can go ahead and assign the number 8 for X. Then we move on to the next set, which is going to be the number of A intersect C. We're going to use the same technique that we used for this previous one. So let's go ahead and clear this out. And we're looking at A intersect C. So once again, we'll go with A. And that's going to be here, 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 and here. And then we're going to go with C, which is going to be this, this. Notice that there's an overlap here. And that's going to be regions Y and W. So that means that for this particular problem, this is going to be Y plus W. And notice that that is equal to 12. But we already know what W is, and that's going to be 8. So Y plus 8 is equal to 16. Is equal to 12. And therefore, Y is going to be equal to 4. So we go ahead and assign 4 right here. Let's go to the next set, which is going to be the number for B intersect C. So once again, let's go back to our program, Microsoft Paint. Okay, and for this one, we're looking at B intersect C. So let's go ahead and fill region B. That'll be this. And then we'll fill region C. And we'll notice that once I fill region C, that we have an overlap between B and C in the regions W and Z. So down here we're going to have this being W plus Z, and that is going to be equal to 11. But we already know what W is, and that's 8. So therefore I have 8 plus Z is equal to 11. Therefore Z will be equal to 3. And I can assign that right here. Notice that I'm still missing regions M, N, and P, but we're going to figure that out pretty quickly. So we're still going to need to use our Venn diagram, and we're going to need to continue to refine it. This next part right here is going to be the number of A intersect C prime, or C complement. That means that's looking at the area that intersects A and everything that's outside of C. So let's go ahead and look at our diagram again. So we look at our diagram, and we're going to have A intersect C prime. So the first thing I want to do is discuss what C prime is. C prime is everything that's outside of C. And then we're going to talk about A. And remember, intersect means anything that overlaps. And A is going to be this. Okay? But we're talking about where they intersect. And that is simply going to be this area right here. And that's going to be regions M and X. So we go ahead and we say that this is equal to M plus X. And that will be equal to 23. But we do know what X is, and that's 8. Therefore, we can write this as M plus 8 is equal to 23. And then we'll subtract 8 from both sides, and we'll end up with the fact that M is equal to 15. And so we can put 15 right in here. The last thing that we need to look at is the fact that N is equal to some number and P is equal to some number. So let's go ahead and look at the number of B intersect C prime is equal to 26. Well, that shouldn't be too hard to figure out because we've actually become quite proficient at that using Microsoft Paint. So we'll go back to this one, and I'm going to go ahead and reset the diagram. And we're going to go ahead and do B intersect C complement. Once again, I want to go ahead and use the fact that C complement is everything that's outside of C. And then we're going to talk about B. B is everything in this circle. And where do the two intersect? Well, the two intersect here and here in regions X and N. Which means that if I go back to my diagrams, I know that X plus N will be equal to 26. I also know from previous work that X is equal to 8. So I'm going to have 8 plus N is equal to 26. If I subtract 8 from both sides, that means that N is equal to 16. I can come up here, I can write in 16. And then I'm left with figuring out what P is. Well, the easiest way to do that is to go back to the one that I haven't finished with. And that's this one right here. Z plus P equals 23. I know that Z is equal to 3. So we'll go ahead and we'll put the 3 in there. And we're going to add to that P, and that will be equal to 23. And if we subtract 3 from both sides, that yields the fact that P is equal to 20. And I have established the cardinality for each one of the regions for this particular given problem.